Hey everyone, welcome back to the deep dive. We're all about taking the latest in machine learning research and making it actually understandable, Because let's face it, there's a lot of dense stuff out there and it's easy to get overwhelmed.
Yeah, absolutely. Especially with so many new preprints coming out all the time, it's tough to keep up.
Totally. So today we're diving deep into a paper that really grabbed our attention. It's called Auspex, Building Threat Modeling Tradecraft into an Artificial Intelligence-based Copilot.
Very interesting title, and it caught my eye too.
Right. What hooked us was that it's using AI for a super critical problem. Cybersecurity threat modeling.
Yeah, a field that's always been a bit of a bottleneck, right?
Right. It's like trying to predict every possible way someone could break into your house, which, can get pretty complex.
It's traditionally very manual, very time-consuming, and often relies on a ton of specialized knowledge.
Exactly. So this paper basically says, hey, what if we could use AI to streamline that whole process and make it way more efficient?
And that's where Auspex comes in. It's like an AI copilot that helps you build threat models. And the secret sauce is this thing they call tradecraft prompting.
Okay, yeah, tradecraft prompting. Definitely need to unpack that a bit. For those who aren't security experts, can you break down what threat modeling even is and why it matters so much?
Absolutely. So imagine you're designing a new app, right? It could be anything, a banking app, a social media platform, you name it. Threat modeling is basically the process of systematically thinking through all the ways that someone could potentially attack that app.
Like hackers and stuff?
Hackers, yeah. But also insiders who might misuse the system, or even just accidental vulnerabilities that could be exploited. So you identify those threats, you figure out how serious they are, and then you come up with ways to prevent them or mitigate the damage if they do happen.
Okay, so it's like a preemptive strike against all the bad things that could happen.
Exactly. It's about proactively building security into your system from the ground up.
Makes sense. So how does Auspex actually do this? The paper lays out their work using this nice, clear SDDSD structure.
Yeah, SDDSD stands for Summary, Detail, Discussion, Synthesis, Deep Dive. It's a great way to organize research like this.
Yeah, very logical. So the summary part basically says that Auspex is a generative AI system. It uses those tradecraft prompts we mentioned to automate and improve threat modeling. It takes in information about the architecture of your system, kind of like blueprints, and then it spits out something called a threat matrix.
Right, which is basically a structured document that lists all the potential threats they have identified, along with things like the types of threats, what kind of damage they could do, and even some initial ideas for how to fix those issues.
So it's like taking all that complicated security stuff and giving you a nice organized report.
Precisely, and it's all powered by this core innovation they're highlighting, tradecraft prompting.
All right, let's dig into the detail part then and really understand how this tradecraft prompting works its magic.
So instead of going the usual route of, say, fine-tuning a huge language model on a massive data set of security incidents, they've taken a different approach.
Which is?
They basically sat down with a bunch of experienced threat modeling experts, and they carefully distilled all that real-world practical knowledge into specific prompts that guide the AI.
So it's like instead of feeding the AI a ton of data and hoping it figures things out, they're giving it very precise instructions based on human expertise.
Yeah, think of it as embedding years of on-the-job learning directly into the AI system.
So Auspex gets like an AI mentor.
Kind of, yeah. And the paper goes on to describe this two-stage process. The first stage is all about understanding the system that you're trying to model. They call it ingestion and analysis.
Like it's gobbling up all the information about the system.
Exactly.
Right?
Whether you give Auspex a diagram of your system, a written description, or even a combination of both, it uses those tradecraft prompts to generate something called a solution description.
Solution description. Okay, what's that?
Think of it as a detailed summary of the system. It gives you a broad overview of the architecture, a more concise description of what the application actually does, and breaks down the key features that matter most from a security perspective.
Ah, so it's like identifying the weak points.
In a way, yeah. It also clearly defines the in-scope components, which are the specific parts of the system that the threat model is going to focus on.
Okay, so it's not just blindly analyzing everything. It's using that expert knowledge to zero in on the most important parts.
Right. And then we move on to stage 2, which is where the threat matrix actually gets generated.
Okay, so how does Auspex take all that information from the solution description and turn it into a list of actual threats and recommendations?
Well, they basically feed the solution description through another set of tradecraft prompts. but these ones are specifically geared towards cybersecurity. This goes into a generative AI model, and out pops the threat matrix.
And what does that matrix look like?
It includes a bunch of things. First, it generates specific threat scenarios. Those are basically concrete examples of how an attack could actually happen.
So it's not just saying, hey, there might be a vulnerability here. It's painting a picture of how someone could exploit that vulnerability.
Exactly. Then, it maps those threats to well-established information security categories, like the CIA triad. Confidentiality, integrity, and availability.
Right, CIA. Just for our listeners, confidentiality means keeping information secret, integrity means making sure the information is accurate, and availability means ensuring the system is up and running when you need it.
Spot on. And Auspex also maps the threats to specific threat types, like those defined by the STRIDE model.
STRIDE, yeah. That's a big one in cybersecurity.
It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Those are like the classic categories we use to think about different kinds of security threats.
So the output is this really structured matrix that links specific threats to these categories, along with some suggestions for how to deal with them.
Yeah, it's about making the whole process more systematic and actionable.
Now, the paper also mentions that they actually got feedback from real cybersecurity experts working with real banking systems.
Yeah, they had these experts evaluate Auspex and the threat models it created, which is a really crucial step. It's one thing to build a cool tool, but it's another thing to have actual practitioners validate that it's actually useful in the real world.
Totally. Okay, so let's shift gears a bit and look at the discussion section of the paper, because they do a nice job of putting this work into context. Threat modeling, it's not exactly a brand new thing, right?
Oh, definitely not. It's been around for a while. Its roots go all the way back to the 60s and 70s, the early days of shared computing.
Back when computers were like the size of a room, right?
Yeah, pretty much. As computers became more interconnected and complex, people started realizing that they needed structured ways to think about security.
Because, the more complicated something gets, the more potential there is for things to go wrong.
Exactly. And that led to the development of more formal frameworks in the late 90s, like Octave and Stride.
Oh, yeah, Stride. We talked about that earlier. It's all about categorizing threats in a systematic way.
Exactly. So those frameworks were a big step forward in making threat modeling more rigorous. And over the years, a bunch of different threat modeling tools have emerged to support these processes.
So it's been a constantly evolving field, just like technology itself has been evolving.
Absolutely. Now, the paper also does a great job of comparing Auspex to other AI-driven security tools that have come out recently. Like, how does it stack up against the competition?
Yeah, let's talk about that. What are some of the other AI-based approaches people are using in this space?
Well, there are several interesting ones. They mentioned CyberCentinel, which focuses more on using large language models to analyze those big security logs you get and to help with incident response.
So it's like after something bad has already happened, CyberCentinel helps you figure out what went wrong.
Yeah, it's more reactive. Then there's a paper by Elsherf et al. That uses a technique called retrieval augmented generation, or ARAG. They basically pull information from system design documents and the National Vulnerability Database to identify potential threats.
So it's like combining existing information to pinpoint vulnerabilities.
Exactly. And then there's StrideGPT, which uses simpler prompts to generate ideas for threats, and Pillar, which is specifically designed for privacy-related threats using the Lin-Dunn framework.
So each one has its own niche, kind of specializing in different areas of security.
Right. And finally, they talk about Threat Modeling LLM, which is a system that's been fine-tuned on a lot of data from banking systems.
Okay, so it's been specifically trained on that type of system. Makes sense.
Yeah. So as you can see, there's a whole spectrum of approaches out there, from analyzing past events to leveraging existing databases and even tailoring models to specific industries.
So where does Auspex fit into all of this? What makes it unique?
The authors really hammer home this point, that Auspex's main differentiator is its reliance on tradecraft prompting. It's not about just having access to tons of external data or doing extensive fine-tuning. It's about embedding that deep expert knowledge directly into the prompts themselves.
So it's about quality over quantity, kind of.
In a way, yeah. And their argument is that this makes Auspex more lightweight and flexible. It can be applied to different kinds of systems without needing tons of specialized data. And potentially, it's more adaptable as new threats emerge because you can update the prompts with the latest knowledge.
So it's like instead of training the AI on yesterday's threats, you're giving it the tools to understand tomorrow's threats.
That's the idea. And they also bring up a really important point. A lot of the AI-based work in this area hasn't been rigorously evaluated by actual threat modeling professionals.
So it's like someone built a fancy hammer, but no one's actually checked if it can, hammer nails.
Exactly. And that's something Auspex specifically addresses with their focus on getting expert feedback.
Makes a lot of sense. Okay, the paper also dives into how Auspex tries to solve some of the persistent problems in traditional threat modeling. What are some of those challenges?
Well, one of the biggest ones is just how resource intensive it can be. It requires a lot of time and effort from skilled professionals. Auspex, with its AI-powered automation, aims to significantly speed up that process and make it more efficient.
So less time spent on tedious tasks, more time for strategic thinking.
Exactly. Another challenge is that threat modeling often relies on really specialized expertise. It can be difficult to find people who have the right skills and experience. And Auspex, by encoding that tradecraft into the prompts, could make these advanced techniques more accessible to people who might not have years of experience under their belts.
Democratizing security expertise, kind of.
That's a great way to put it. And then there's the issue of standardization, or rather the lack of it. Threat models are often created in different ways, using different formats, which can make it hard to compare and share them effectively.
Yeah, it's like everyone's speaking a slightly different language.
Right. And Auspex addresses that by producing a standardized threat matrix as its output.
So it's bringing some order to the chaos.
Exactly. They also talk about how hard it is to keep threat models up to date, as systems evolve and new threats emerge.
Which happens all the time in the tech world.
All the time. And Auspex's flexible prompting approach could make it easier to adapt and refresh those models as needed.
So it's a more agile way to deal with a constantly changing threat landscape.
Absolutely. And finally, they mentioned the potential for integrating threat modeling earlier in the software development lifecycle. Traditionally, it's often done later in the process, which can be problematic if you discover major security issues when it's already too late to fix them easily.
Yeah, like it's better to find the cracks in the foundation before you've built the whole house.
Exactly. So Auspex could help shift threat modeling to the left, as they say, making it a more integral part of the development process from the very beginning.
Sounds like they're really trying to address some of the most fundamental pain points in the field.
They are, and the results from their evaluation are really encouraging. Those cybersecurity experts who looked at the threat models generated by Auspex, they generally found the scenarios to be clear, understandable, and realistic. They weren't just, theoretical possibilities, they were plausible attack scenarios.
Yeah, and the paper mentions this thing called Hamming loss, which is like a way to measure how well Auspex's threat categorization matched up with what the human experts thought.
Right. And they found a low Hamming loss, which basically means that Auspex was pretty darn good at categorizing the threats according to those established frameworks like STRIDE and CIA. So it seems like it's aligning pretty well with expert judgment.
That's good to hear. Although they did mention one outlier. That platform-level system that didn't perform as well.
Yeah, that's an interesting point. It suggests that the effectiveness of this approach might vary depending on the specific characteristics of the system you're analyzing.
Makes sense. It's like a one-size-fits-all solution might not work for every single situation.
Right, so maybe they need to refine the prompts a bit more for different types of systems.
Okay, so this brings us to our favorite part of the show, the part where we let our imaginations run wild. Novel notions.
Always fun to speculate.
So building on this whole idea of tradecraft prompting and Auspex, what are some crazy out there research directions that we could imagine?
What really fascinates me about tradecraft prompting is that we're essentially codifying expert knowledge in a way that AI can understand and use. And that got me thinking, what if we went a step further and actually analyze the tradecraft prompts themselves?
Like analyzing the analysis, meta-analysis almost.
Exactly. I'm calling it meta tradecraft analysis.
Yeah.
What if we use machine learning to identify potential gaps, biases, or even inconsistencies in the accumulated knowledge that we've encoded into those prompts?
So we're building an AI to double-check the AI that's doing the threat modeling.
Precisely. Think about it. Those expert insights, they're based on past experiences and existing knowledge. But what if there are blind spots in that knowledge? What if there are certain types of attacks that haven't been prevalent in the past, but could become a big deal in the future?
Like the AI could potentially see things that the human experts might have missed.
That's the hope. And the way this could work is you train a separate AI model on a massive data set of historical security incidents. Successful attacks, patterns of vulnerabilities, maybe even the outputs from systems like Auspex itself.
So it's like feeding the AI a history of everything that's gone wrong in the past and seeing if it can spot any trends that we might have overlooked.
Exactly. And the goal is to see if this new AI can identify types of threats that the encoded tradecraft and Auspex might not be explicitly considering. And then you use that insight to refine the tradecraft prompts themselves. So you create this continuous loop of improvement.
So the AI is not just doing the threat modeling, it's helping us learn how to do threat modeling better. It's like a constant feedback loop between human expertise and AI analysis.
That's the vision. And this whole idea of meta tradecraft analysis, it can have some really interesting implications, like what if it revealed some hidden biases in our understanding of cybersecurity?
Like, what if we're focusing too much on certain types of attacks because they've been common in the past and neglecting other types of attacks that might be less frequent but potentially way more devastating?
Exactly. This kind of analysis could help us achieve a more balanced and comprehensive approach to security.
And maybe, just maybe, it could even lead to the AI identifying entirely new attack vectors that we haven't even thought of yet.
That's a mind-blowing thought, right? An AI that's pushing the boundaries of our knowledge beyond what we currently understand.
That's the beauty of AI, right? It can help us see the world in new ways. But of course, these are all just speculative ideas, just food for thought.
Absolutely. But it's fun to explore these possibilities.
Definitely. All right, so to wrap things up, the Auspex paper offers a really cool new approach to cybersecurity threat modeling. This idea of tradecraft prompting, it's about taking expert knowledge and translating it into something that AI can use to automate and enhance this vital process. It could potentially make threat modeling faster, more accessible, more standardized, and ultimately more effective. If you're interested in the technical details, definitely check out the full paper. The link is in the description. And as you think about this, consider this question. As we rely more and more on AI to secure our systems, how do we make sure that the expert knowledge we're embedding is truly comprehensive, free of bias, and constantly evolving to keep up with the ever-changing world of threats?
That's the million-dollar question.
It really is. Thanks for joining us for this deep dive into Auspex and the future of AI-driven security.
Always a pleasure.
We'll catch you next time on The Deep Dive.